While the emphasis on training programmers is usually about taking a clean sheet of paper and creating software from scratch. In fact, in the real world, most software doesn't work that way. Most software ends up taking existing code and modifying it to add features, change purpose, and so on. In other words, most software work is on existing code, not on a clean slate. And these days, even if you have a supposed clean slate, you don't write all the code. It's very, very common to take existing components and plug them together, and most of the new code writing is glue between the components. This is especially true using open source components. The notion that most code is maintenance isn't a new one. There's the 60-60 rule from 2001, and the 60-60 rule states that maintenance can average 60% of lifecycle cost. In other words, most of the cost of software happens after you release it, not before. And I've heard other numbers that say it's more like 80%. So clearly, the cost after you release the software dominates the entire cost of the software lifecycle. Furthermore, about 60% of the maintenance is adding new features rather than fixing bugs. Now, if that weren't bad enough, usually maintenance is harder than primary development. And the reason this is that you need to understand the existing system. Going into a million lines of code and trying to understand what's going on can be a lot harder than just saying, forget it, I'm just going to start from scratch. But the problem is with a million lines of code, you usually cannot afford to start from scratch. So you have to figure out what's going on with the entire system. If you've had an entire V process that has documentation and that documentation is up to date, then that helps you with maintenance because now you have a starting point. You're not starting from a bunch of code. You actually know what the requirements are. You actually know what the test plan is, and so on. Related to this is that optimized code is more painful to maintain. Optimized code is usually harder to understand but runs faster, but heaven help you if you have to actually change it. The important part of maintenance is the ability to modify a system without breaking things. So you need to understand what the system's doing. You need to understand all the dependencies. Hopefully they're documented so you don't have to figure them out for yourself. And you need to make changes without breaking things. Most programmers eventually get to a place where they look at a big mess of code and say, you know, this is going to be easier to rewrite and throw away than it is going to be to fix. And the problem is that doesn't scale. A related thought is, if the original programmer ended up with a big mess, why do you think you're going to be any different? If you're going to use the same process and the same approach, all you'll end up with is a big pile of spaghetti that you understand but no one else can.